This is a conversation with Christian Fritz, who is the CEO and founder of Transitive Robotics. Transitive Robotics makes software for building full-stack robotics applications, meaning that it aims to make connecting your robot to a user interface easier. Some reasons you might want to do this are to remotely monitor the health of robot fleets, see what a robot's camera sees, or to teleoperate a robot. Transitive Robotics does this while solving the hard networking problem of robots potentially coming into and out of connectivity. I enjoyed talking to Christian. His perspective in forming Transitive Robotics seems to have been very pragmatic, and in my opinion, Transitive Robotics is building a tool that is very needed by the robotics community. It was also interesting to hear his thoughts on growing a robotics app marketplace, which may be in Transitive's future. This is the SenseSync Act podcast. I'm Audrow Nash. Thank you to our founding sponsor, Open Robotics. And now, here's my conversation with Christian. Hi, Christian. Would you introduce yourself?
Hi, Audrow. Hi, I'm Christian Fritz. I'm the founder of Transitive Robotics. People may know a little bit from my career where I'm coming from. I used to be the head of software at Savioke. And for those who don't know Savioke makes a really cute delivery robot for hotels and hospitals. And it was a really fun ride for me being there. I started when there were about 5 robots in the field. When I left, there were over 100. And it was really an eye-opening experience for me. My background is in robotics. I've done RoboCup back in 2001. I've seen all sorts of versions of robotics, including before ROS, which was very painful. And then at Savioke, I learned about not just the robotics piece, but the full stack that went on top of that. So that's really kind of my background. I was leading the application development team there, which basically, I always described it to new candidates or new employees as follows. The application development team gets a robot that knows how to stay localized and not bump into anything and turns it into value to the customer. So what that meant was all of the HRI was done by our team. Anything that involves this sense of a mission, right? Like running a delivery, the notion of delivery, riding elevators, calling phones, notifying users, all of that was done by my team. And it was a really interesting experience because I found out that while ROS is really great, there's so much more that you need in order to deploy a successful robotics fleet in the real world. And so that's how I came to start Transitive.
Now, what exactly are you doing at Transitive? Like, how are you solving this deployment problem and the problems that you kind of saw from your work at Savioke?
So at Savioke, we spend a lot of time building, those full stack applications, data synchronization between robots and the cloud and the front end, visualizing elements of the robot such as maps and laser scans, and sending data back and forth and doing all of that DevOps. And it was really interesting for me to find out that other people at other companies like Fetch Robotics and other places that we spoke with were basically building the exact same thing, right? So we felt that's not a good idea. And granted, there are some solutions out there that help try to offer kind of a one-stop shop for fleet management and DevOps. And some of them are actually done by friends of ours, and they approached us at Savioke to see whether we would want to use them. But the problem that we had with them was that they all are standalone platforms. So really, they give you the choice of, do I build my own fleet management or do I outsource that? And the issue that we had with that was that when you outsource it, your hands are tied. If the thing is not perfect, you cannot extend it. And if there's something that you need, you still have to build it separately. And then you have, first of all, some double work, but also you are duplicating your data landscape, right? Some data will live in the one silo, the other in your own.
You mean in the software you're using for fleet management, and then whatever features you build custom yourself kind of outside of that for your own fleet management?
Yeah, that's exactly right. Yeah, exactly right. So you will have separate users on different accounts. You have different roles. You will have
complex.
Some data about the robot. Yeah. And so what struck us was that what people really want is the ability to just take individual components and plug them into your existing web application. A good example of that is low latency video streaming. Almost everybody wants the ability to see what the robot is currently seeing. And it's a complicated application or capability to implement because there's some really great technology like the one that we're using here right now, which is WebRTC, which is running in the background. It's very complex. And a lot of robotics companies don't want to get into, don't want to become experts at that. They don't want to get into the weeds. So at Transitive, we're basically developing these things as individual components. That's the one thing that's different about us from the existing offerings out there. And the other one is that we believe in open source. So we're actually following an open core model where the platform that we're developing will be open source and anybody can use it, and we hope people will, and they will build cool things on top of that. And this is really kind of a philosophical thing for us. We think that Ross has done such a good job at uniting the robotics community by giving us a common platform that we can build packages on, and so we can share, right? So if you build a really awesome navigation functionality, I'm thinking of your last episode, you can share that with the world, and the world will be a better place, right? And I think Ross has done such a tremendous job at establishing that framework or platform based on which we can share, and we would really love to do the same now for the full stack. If it's open source and it's easy to implement new capabilities, then we really think that people will start contributing back, and we can finally stop all reinventing the wheel and building the same capabilities.
Yeah, for everyone who has a fleet of robots that needs to manage them in some way. So now one thing I'd like to do, just kind of going more into detail, what does it mean to do fleet management, and what are some of the challenges with fleet management?
Well, so I'd start perhaps a little bit lower and start with why fleet management or anything to do with robotics is not just another React app or something else where you can use common tools out there and they don't just solve the problem. And the big one is really that these robots, as much as they seem to behave like servers, are not really servers because they roam around, they lose network connectivity, they gather data faster than anybody can process them. And so you have some unique requirements in creating a uniform picture of your fleet in the front end. And this is not very unlike what some of the cloud providers offer with their IoT.
And when we say front end, you mean like a web browser or some...
A web browser. Yeah. It's, yeah, I guess I should say that.
That's why I'm asking.
No, it's a good point, because in robotics, and especially in ROS, a lot of Qt applications are still being used for front end. We think that if you are dealing with a broad set of users who are distributed, have different backgrounds and so forth, using web technology is really the way to go, because everybody knows how to use them. Obviously, most of the software being developed these days runs on some form of web technology, and it's just a very lively and flourishing ecosystem. So using web tools, I think, is the best approach for building these front ends. And so, and at that point, you have to create a link between your robot gathering data and the user sitting in front of a browser.
Okay, so for fleet management, web-related tools are really good because they let you, it's better, there's really good tooling around there, there's a good ecosystem, this kind of thing. And I guess getting into kind of the fleet, so, and then actually you were saying that a server, like you can't just treat it like a robot like a normal server. And so because of that, you at Transitive Robotics, you're trying to make it so that you can, in a sense, treat a robot like a server while addressing some of those challenges?
Yeah, that's exactly right. I think it kind of comes down to the core abilities that the platform gives you as a developer. And one of them, and I think that's perhaps the most important one, is the data model. that it gives you. And what we're doing there is actually not very different from what some of the cloud providers offer in their IoT solutions. On AWS, they call them IoT shadows. In Azure, they call them desired and reported state of a robot. The idea is always the same, that you have some form of data model that tells the robot, this is what I want you to be like, whatever that is, configuration, deployment.
So does it tell it the state robot to get into, basically? So it's saying I want...
You can think of it as a...
Yeah, go ahead.
You can think of it as a state, yeah. And the state can have all sorts of aspects to it, right? Like which software to run, what users to have, what configuration values to use, which cloud to connect to, and so forth. And then the problem is your robot sometimes is not online, right? So you have to make sure that you reliably synchronize that data to the robot and also get the data back. On the coming back side, you have that same issue that you may want to monitor your robot while it is traversing through some areas where it has very poor connectivity, but you don't want the front-end experience to be chopped up, right? You want the user to have a smooth experience and still see the robot, even if right now you can't get signal from it. And that's why it is not a server. You can't just run a web server on it and have the user connect to it directly.
Is that kind of the biggest challenge in this, would you say, where it's the robot comes in and out of connectivity and it makes it so that you can't make a lot of the assumptions that people would make about like web servers in general?
I think that's a good way of putting it, yeah.
So what do you do in the case that how do you make a smooth experience when a robot is popping in and out of connectivity?
I think really the key here is an intelligent data synchronization, where the robot essentially updates the cloud whenever it has connectivity, and then the cloud serves the user's front end, right? So the user always sees data. Sometimes data will be a little bit delayed because the robot hasn't gotten an update through to the cloud, but the cloud will be able to tell, hey, I haven't gotten a heartbeat from this robot in 10 seconds, so what you're seeing may be a little bit old. Right? But from the user's perspective, pages load fine, everything will be there, and you will always see the latest data that you could possibly get independent of when you showed up.
Gotcha.
Some people think that you could just run a web server on the robot itself and then connect. And then the problem is sometimes you try to load the page and it just doesn't load because your server is down or not connected.
You mean actually host the website from the robot?
That's how. So let's take an alternative. Some people RVIS into the robot, right? RVIS for your non-ROS users is a visualization tool for ROS, and it's an awesome tool. But it's not really meant to be used remotely for several reasons. One, it sends a humongous amount of data because it actually thinks that the connection is very good and fast and sending duplicate data is not a problem. And it also just sends a ton of data. So there's not a lot of filtering typically going on, which means that the remote experience with RVIS can be very choppy. And then the robot goes in and out of connectivity sometimes. So
you lose it.
You will have a lot of disruptions. You lose it. Yeah. So I think some kind of caching of the data in the cloud, that's one. Reducing the amount of data that you send from the robot to the cloud is another one.
Oh, yeah, that's an important point, reducing it so that you don't actually spend that many resources on kind of, I don't know, perhaps you can get by with less, and then you have less requirements of your connectivity to your network.
Yeah, that's exactly right. A good example here is health monitoring. A lot of your listeners may be familiar with how ROS solves the diagnostics problem, where there is a nice hierarchy of message definitions that allow you to share diagnostic information about your robot, such as sensor values, battery state, and so forth. But the way that ROS publishes that is, hey, here's an update, here's an update, here's an update, even if nothing changes, right? And that's fine with ROS. That's how ROS is designed on the robot, and that's good. It's actually a good approach on the robot, but not for the cloud, because you don't want to repeat messages if they're literally the same as the previous one. So even just deduplicating sequences of messages will already save you a ton of data.
Yes. So how I'm understanding what it sounds like you're describing. So if you want some sort of way of monitoring your robot. Your robot has information, it's driving around, it may move in and out of networks. What you're doing is you're placing a cloud component, so some computer somewhere else that's talking to the robot. This is basically, it's keeping up the whole time, and it's displaying whatever the most relevant data is on there. And then I suppose, well, actually, and then you have the user who looks at whatever the cloud is doing. So the cloud has its own host, its own website it's hosting, and the user can look at that and get to see the state of the robot. And then I assume on the robot you have something that's saying this is necessary information to send up to the cloud. So if it's a repeated message that's being sent, you don't bother sending it again because of limited bandwidth, effectively, to try to send data to the cloud. Like, you only want to prioritize and send the most important updates, probably, to the cloud.
Yeah, that's exactly right. That's exactly right. And the way that these decisions are made is that we believe in vertically integrated capabilities. So what I described so far is this very fundamental data synchronization layer.
Mm-hmm.
But then what you build on top of that, we think in terms of apps, right? So let's take a remote teleoff capability. A lot of people need that on the robot. So that involves sending video from the robot to the front end, displaying the video on the front end, and sending back some control signals from the joystick. The way that Transitive is structured is that we have this concept, a very strong concept of packages, similar to ROS.
Mm-hmm.
But what's special about Transitive is that inside a package, you don't just have components that run on the robot or the cloud or the front end. You have all of them together. And what's great about that is that you have an end-to-end exchange. And if you want to change the way that things are visualized on the front end, and you need, say, some new data that you didn't have in the previous version, it's fine, because you're going to publish another version of the code that runs on the robot and pushes to the cloud as well.
Mm-hmm.
So this gives you some really nice, we think of this as cross-device dependency management.
Yeah.
You don't have to worry about, oh, well, we just upgraded our front end, so we now also need to upgrade our backend. It's all taken care of.
Yeah.
Yeah.
Interesting. Okay. So going back, so some of the challenges with fleet management, we have basically the connectivity issue where it's going in and out of the network. We have perhaps so you have the robot, it's sending data back and forth. The robot may or may not be connected. You have health monitoring and things like this, checking the status of the system. And you have updating it, which you've kind of just mentioned. You can ship things as components and it's updated universally. Are those kind of are there additional challenges to fleet management? Network updates and, I forget the second, but yes, those. Are there additional ones that are kind of critical in fleet management? Health monitoring checks?
Actually, if you don't mind, I'm going to share can I share my screen real brief?
Yeah, of course.
So this is a list that we've put together of things that we needed at one point or the other in the past. And it's grouped by categories of kind of apps or capabilities that you might need to run a fleet successfully. So there's the category of DevOps and fleet management, soft joystick, remote teleop, low latency video, easy ROS-back viewing, health monitoring, and it goes on. Observability is a big one, alerting, right? A lot of people like to integrate with PagerDuty and so forth. But then there's also things like application logic, right? Task entry, queuing of tasks, user management, account management, and a lot of those things are really not that much fun. So they're not really they're not differentiating to a robotics company, right? So we validated this with a lot of CEOs and CTOs of robotics startups, and they always said the same thing. There are certain things that we would like to focus on. Often in the ML or computer vision space. We were talking with an apple-picking robotics company. You can probably guess who that was. And they said, well, our secret sauce is in our ability to identify grasping points from the computer vision. We would never want to outsource that. And that's where we want to differentiate ourselves. But there are so many things on your list, like CI/CD, like anomaly detection. That's not important to us. We would love to outsource that, and that's how we think about Transitive: both a platform to develop those kind of capabilities, and then also a company that will offer them.
Yes. Do you? So where are you guys currently in this? Because the list of things, there must be like 40 items or some large number of things that all seem really important to shipping a robot application. Do you have all these implemented, or is it like a set of them, or where you at?
Yeah, no, not at all. This is the aspirational slide, so to say, and it's also meant to perhaps give people ideas of what they could develop and contribute. This is really the motivation to do all of that, and the way we're going about it is we want to develop the platform first, open source it, and then start building the ecosystem to develop all of them. Yep. Right now, if you go to our website, there's 3 capabilities that you can try out right away. And they are some of the ones that I've talked about so far: the low latency video streaming, remote teleop, and health monitoring. Everything else, so TBD.
Yeah. So it's so you have this list. You kind of gathered this list, and I assume maybe it was somewhat iterative in the process. But so I assume this really informed the data model that you're using and the development of the system, so that you could fit all these cases under your framework.
That's exactly how we were thinking about it.
Gotcha. That's really cool. So I'm kind of imagining this is like I'm mapping it to like web concepts. It's eventually going to be like the hosting service for robotics applications. Probably you have your specific logic running on your robot. If you're using the ROS ecosystem, you get a lot of things for free that might be good enough for your applications, like navigation or grab move it for motion planning of arms, these kinds of things. And then you have this to make it so you can quickly build your web interface to monitor your application from the people that should make sure the robots are running, or I don't know, whatever it is that's engaging with your robots, or whoever it is, so whatever they're doing.
We're thinking about this in 2 different ways. One is to get people started more quickly, so that they don't need to build these things. And then sometimes our investors ask, well, aren't you going to lose those people once they grow to a certain scale, and they will not care because they now have 200 employees and they will build it themselves? And my answer to that is they still would not want to. And the reason is, my counterexample is Slack. Why do people use Slack? It's not impossible to write your own chat.
It's pretty trivial, in fact.
It's pretty trivial. However, are you really going to make it quite as well as Slack?
And that's all they do.
Exactly. It's the value of specialization, right? And in the end, you will use the best solution out there. Startups, especially in robotics, are actually not as price sensitive as you may think. And that's because the BOM cost of robots, all of the operations, it's not that cheap. So if they have to shell out $20 a month for a capability that works really well, who cares? They're spending more on the LTE bill per robot, right? So I actually think, and this is something that I've felt with ROS too, is that I think ROS would actually benefit from more entities having a business plan behind them and commercial backing, so that the contributions that are being made by those companies to ROS have a longer outlook, right? There's some real money behind it. We can be certain that they will be maintained, and there's somebody on the hook for making sure that they work
well.
Right? Yeah, there was this really. I think at Roswell last year, somebody presented this paper. I think it was called something like "It Takes a Village." I forget the details. Do you remember that paper?
I don't think I saw it.
It was really interesting because they did a study of ROS packages and which are used, like how many people use them, and how well maintained they are. And it was really striking that there are some, like the core modules they're all being used by almost everybody. But then the vast majority of packages, and of course there's a ton of packages, right? They are not maintained very well, and so that puts users in a difficult spot. And in deciding of, can I really rely on this package, or do I have to fork it if I want to use it? And I think that the JavaScript community does a very good job at that with the npm package manager, where with every package that you can find on their site, they will show you how well is it maintained, meaning how many commits have there been made lately, how popular is it, how many people use it, and I think some other metric. And I think that's very helpful. Quality, some sort of quality
metric. I don't know how they get that, but it's quite cool.
I think it's very helpful, and when I choose libraries to use, that's definitely something that I look at. And
for sure,
knowing that there's others who use it is sometimes perhaps the most important factor, because I know that if I run into issues, I will not be alone. There will be others who
are also invested in it, and thus you can feel a little more secure in that other people might pick up some of the slack. You can pick up some of the slack, but it's not entirely on you to maintain. If the developer just goes silent in maintaining it.
Yep.
Gotcha.
And I think if we can stand something like that up, here we're obviously taking the perspective of the full stack, but I think some of those ideas translate into other ROS packages as well. And one thing that we haven't touched on yet is you could have a ROS package be part of one of these apps, right? You can, the way that we've actually designed our deployment mechanism, these packages can contain whatever you want. Some people cringe when they hear whatever you want because that sounds dangerous, and we can talk about sandboxing in a second.
Yeah,
but
actually,
it's pretty powerful.
For sure.
Yeah, so we've designed this from the bottom up as a framework that.
What are the components? So in any one of these packages, or in any of these components, it has the robot part, or what are the parts of it that are involved, and how do they talk? And then sandboxing sounds very interesting to talk about too.
Okay, so let's dive a little deeper. Before we get into that, I think I should mention that we're using MQQT as the underlying communication mechanism for just about everything, and I think that will help our conversation here.
I don't know much about. I don't know anything about that.
Oh, okay. So MQTT is a pub/sub mechanism where you have topics that are hierarchical, separated by slashes, just like a path in Unix.
Okay. Very similar to ROS topics, it seems like, from the description so far, in a sense that you have topics and then it's hierarchical, like namespacing and this kind of thing.
That's right. I think the main difference to ROS topics is that they don't have this notion of a message definition. Any message in the end is just a buffer or a string, like a character buffer. And it's then on the receiving end where you will interpret
process it. I see.
So, yeah. And other than that, I mean, it's a very well-developed technology. It's actually underneath all of the IoT cloud offerings, like AWS, GCP, and Azure, all built on MQTT. Okay. So it's sort of battle-tested, and it's meant for IoT devices, so for low resource usage, a very high throughput communication. And unlike ROS, it was really meant to be cross-device, right? Like the typical IoT application, you have a large fleet of small devices that all send data to the cloud and from there potentially onwards. So this seems like a very good technology to build this on. And then our packages, they are exactly like you suggested. They actually have three components. There's the code that will get installed in the robot. There's the code that will run in the cloud in a Docker container. And then the third piece is are any sort of front-end components. And there we are using this new technology called web components. It's not a very good name because it's not very unique, but web components is a thing. And it's very nice because it's front-end framework agnostic. You can use it in React or Angular or even without any of that. So it really just, it's like a custom tag in HTML. So you can, once you've loaded that component, you can just type, pointy brackets, name of your component, and it will appear where you want it to be. That's what we use for the front end. And then underneath, they all communicate through MQTT in a namespace that is not just specific to the capability, but actually even to the version of the capability. And this is what allows us to create this cross-device dependency management. This was a very big pain point that I've faced at one point in my career, where if you update the cloud, you may be forced to also update all of your robots. depending on what you've changed on the cloud. Now, guess what? Your robots, if you have more than 100 robots, at no point in time will all of your robots be online at the same time.
Mm-hmm.
So when do you make the switch, right? And so there's different ways to deal with it. Some people
you kind of just keep both, and you just have them send their version messages. Or,
that's how we are solving it. Exactly.
That's super cool. And then you kind of delete it once they are all on board with the most recent version.
And the cloud will know nobody has been talking to me on that version for a month, so I'm just going to shut off that Docker container.
That's super cool. Okay, so you use MQTT. This gives you that really nice version messaging behavior. That makes updates really cool. And I really like the idea of kind of it trickles in as the robots become available. Okay.
So that tells you how the three components in the
Would you say the three again, together? Just explicitly?
The robot,
yep.
The cloud, and the UI.
Okay. And so for these components, one thing, so are they all, how do you get them to talk to, like, so if I'm writing one of these components, how does it look? Like, how can I test all of these? What do you call with the components within the component, or how do you refer to the web robots and cloud parts of a component?
We should get that terminology down better. We don't have a good name for them yet.
Gotcha. But component makes me think React components, which is kind of and then that makes me think just the web part of what your thing is. But
we could call them modules. Well, actually, right now we're referring to this whole thing as a capability.
Capability, okay.
And then the three underneath are packages or modules. But
okay,
the
so you have a capability and a
capability.
Gotcha. Mm-hmm. Okay, I like the word capability better for discussing it, just so it's not as overloaded in my head. So how do you write a module, or how do you write a capability and test all these modules? How do they work from a developer's point of view?
Mm-hmm. Some of this is still being developed right now. We have not yet made the open source release. And one thing that we want to get done well is the SDK, which is kind of what you're asking about, right? So there will be tools that will allow you to create new capabilities quickly, in the sense that they will be, I'm taking a lot of inspiration from, again, how things like React have solved this, where you have a CLI tool that's where you might say, transitive, create new capability, whatever, and it will set up the directory structure and the package JSONs and the webpack, whatever you need in order to compile out of those.
Yes.
We do use, I guess might have to say that we do use NPM exhaustively. And for those of you who don't know NPM, it's the Node Package Manager. It's a very nice tool. A lot of people think like it's only for Node, but it turns out you can put anything you want into that package. It has a lot of advantages over, say, Debian packages. That is probably too much detail to go into, but
I would be interested
they give us a lot of
mechanisms. Talk about it just a bit later in the interview. Yeah, go ahead.
So once you have these NPM packages, there's scripts that you can have for npm publish to publish those packages of your capability into a private registry or an Artifactory store, and from there your robots will be able to pull them and run them. The connections that you were asking about for communication will be set up through that data synchronization. So from the developer's point of view, all you're manipulating is actually one big JSON object, and within that JSON object, you can decide which subpaths you want to subscribe to and which ones you want to publish. But you will always be dealing with that JSON object as if it was just on your machine. And
you mean the thing that's being passed between the modules and the capability, correct? So you're sending that JSON object around, and that JSON object, so that's a data structure for viewing everything. JavaScript object notation or whatever it stands for. Okay.
That's what it stands for. And the data synchronization that I mentioned previously basically just takes care of making sure that what the robot sees from that JSON is exactly the same as what the capability in the front end sees. And you don't have to worry about it. You just manipulate it on the robot, and you will get to see it like that on the front end. And for those of your listeners who know how reactive web programming works, this is a reactive data source. So if something changes here, your React component will update dynamically. You don't have to poll. You don't have to worry about it. MQQT will take care of the push. And in the moment there's a change on the robot, you will see it on the front end without ever polling.
So what that means is that the second the robot sends a new image from the camera, is your component updates and shows that new image, correct? The web component?
I wouldn't necessarily use images as an example here, but because that I would
it's more complex,
send
perhaps
over WebRTC and with good compression. But the example still holds. If you could do that, you could send an image over that channel. Another example would be let's say the battery charge. If your battery charge
that's probably a better example because no WebRTC,
it will show up right away on the front end.
That's really cool. So how if I'm developing this, if I'm writing my own capability, how do I test that all of the 3 modules are working well for the capability? Is there any I don't know, the thing that makes sure that all of them are working well together, that data is being sent around, that I can test my component, my module for the web browser locally, these kinds of things, storyboards for all these things.
There's not a lot.
Web component.
There's not a lot of tooling yet, so some of these automated checks that you're alluding to don't yet exist. But there's definitely the developer workflow and the documentation on how to run it locally in a development server, so that you can try this out. And I think that's a good way to get started. You can even use a simulator to run your robot, whatever. We use TurtleSim a lot, which honestly is enough. For a lot of what we want to do. And then you open a local web page on your machine, and you will be able to see whether things are working.
Gotcha. That seems super cool. And what is so in the cloud component, so there's the web, the cloud, the robot. What does the cloud component do?
So the cloud component is actually a very...
cloud module.
Thank you. The cloud module. There's obviously what you want the functionality to be. There can be visualizations and so forth. But before it can get there, what the transitive wrapping for that module does is twofold. One, and that's very important, is authentication and authorization. Because if you want to embed this component in a third-party web application, you need to get the appropriate permissions to actually show the data of the robot, right? I mean, you don't want the camera of your robot to be publicly available on the internet, and obfuscation is not enough. You want some really strong authentication. The way that we solve that is through JSON Web Tokens, which is a security technology. It basically allows you to take a JSON object and sign it with an asymmetric or symmetric key, depending on what you choose. And we use that to basically get permission from the back end of your service, whatever you're embedding it in, to show certain things to the user. So you will basically give your user a signed JSON Web Token that says this user has permission to see this device, this capability for this and that long. And then it will be embedded in the web page that your user goes to. That web page will talk to the transitive server, whether you host it yourself or whether you use our Transitive Robotics hosting. And it will let us know whether or not we are allowed to show the user that kind of data. So that's all taken care of. Yeah, whether they're authorized to see that. And that by itself solves a big pain point that a lot of people struggle with, just this user management.
For sure.
It's complex, and we've seen some very successful companies offering authentication as a service, right? Auth0, Okta, and for a good reason. It's not a lot of fun, and if you make a mistake, a lot is at stake, right? Your company, you may be sharing too much data than you wish you were.
Yeah, and I think that's an area where it's like, oh, you need to go be an expert to do well. And so it's nice to specialize there and have another company that just does this really well, so you don't have to worry about doing this for your application. So the cloud component for any of these capabilities you're making is going to handle the authentication and authorization. I imagine that's kind of like baked in to what you're building, so they don't probably have to handle that when writing their application. Does it also handle, is it on the robot that it's running? Like, I know that sounds silly, but is it the thing that sends the information up to the cloud, or is it actually running on the cloud? And
it's actually, yeah, you mean where the authentication is going to be processed?
Or, I mean, well, I guess, so the authentication, that's, I guess I'm a little confused because so for that, I would think that that would be something that you would set up very well, and maybe all the code lives in the cloud component, and the person the developer hardly touches the cloud one. It just like, because I don't think like if I want to use this to write a capability, I don't probably want to do the authentication and authorization side. So I'm imagining that's probably generated or exists in something that's already being used, like my code is using.
Yeah, absolutely. That's part of the essence of the framework, and it's actually a feature of the MQTT broker that we're using, where you can have custom authentication and authorization, which we Transitive offer, right? So the way it works is that the web component actually establishes an MQTT connection over WebSockets. Okay. And in order to authenticate for that connection, it will send its signed JSON web token. The MQTT broker will interpret that and say, first of all, yes, you are who you claim you are, because this is a valid JSON, a valid GWT. And also, I've decoded that JSON web token, and in it, it says you have access to the following topics. And this can be read or write access. And that's all you need, right? Because again, this is the beauty of relying on MQTT for everything. Now you know that the broker knows which messages it is allowed to send you and which ones you are allowed to write. And then it kind of goes into the ether, and everybody connected to that gets it. Yeah,
yeah, that's magic. That's so cool. I feel like it's taking such a painful problem and making it a lot less painful. So the cloud, if I'm a developer writing my own capability, the cloud component, I will probably have the ability to use the default way of doing authentication and authorization, or I can write a custom one if I desire. And that's kind of all the cloud component does, or is there anything else?
Well, I mean, the other thing that the cloud component does is, of course, the data synchronization piece, right? So that in the cloud component, you have immediately access to, you can subscribe to a subset of the topics that you want, and the data will magically appear on your doorstep, and then you can visualize it in whichever way you want, so that you can really focus on just that, right? How do I present the data? So, imagine you're a little black. I like to think in terms of black boxes. If you're a web component, you're a black box, and you receive, after all of the magic has happened, you receive a JSON object. And what you're responsible for is outputting a nicely rendered HTML page or whatever, or React, whatever you want to use to visualize that data, right? Health monitoring is a good example. Again, like you get a JSON object that represents the health of your fleet, and you decide to show that as a table with red and yellow and green and what have you, right? That's really what people want to use web components for. They don't want to spend too much time on the plumbing, as I call it. They just want to visualize it. And then in the reverse, the same, right? So your joystick component says the user has been pressing the forward button. Now you need to send that to the robot. So you will send the appropriate data into the pipe on that topic where you know the robot will be listening.
Gotcha. That's really cool. What does it look like on the robot? How do you set it up, and what's actually running on your robots when you actually are using this?
So the way to get started, and it depends a little bit on whether you want to use the hosted solution that we offer or whether you want to self-host. But in the hosted solution, you just go to our website, you create an account, and you will get a curl script that you can run on your robot, which will install the Transitive Robotics agent. This is just a small little piece of software that runs on the robot, and it's primarily responsible for checking whether you are running, which packages are installed, which packages should be installed, and then installing them and starting them. And then once it is told to install a certain capability, it will fetch that from the repository and install it and run it in a sandbox. The sandbox is one of the other pieces that is really important to the way that we're thinking about this, because we want to enable third parties to develop for you. We think that sandboxing is really important.
So tell me what sandboxing is. I know what it means, but just like describe it.
So the issue is always that when you're getting software from a third party, you may not want to trust it 100%. So you want to reduce basically the damage it can do. You want to reduce the permissions that it has. Both iOS and Android have very, very strong sandboxing models. So if you install an app on your phone, it won't be able to read the password from your other apps, right? Which is kind of important.
Yeah.
And the same thing here, right? In the ROS world, people are used to using sudo to install ROS packages, and that's a very honorable thing to do, I suppose, to give that much trust. But if you are dealing with a much larger ecosystem, you may want to be a little bit more careful about the trust that you give and not run everything as root.
For sure.
And a lot of people wouldn't even want to run it in the normal user space, because even the running user could have secrets and so forth. That's one thing. The other thing is you want to separate the capabilities running on your robot from one another so that they cannot see each other's data. Otherwise, the authentication and authorization goes out of the window, because somebody could install a malicious.
See everything.
Yeah, a malicious capability could just listen in on everybody else. So we are solving this through a number of technologies that all borrow from Docker. We do not use Docker on the robot because we don't want to require that as a requirement. But we use some of the same technologies. We use the Linux namespaces, using the unshare tool to isolate things. This allows us to do pretty cool things, honestly, without requiring sudo on the robot. For instance, we can hide a lot of folders on the drive. We can hide the home folders, and then we're also using OverlayFS, which is a technology exhaustively used by Docker to minimize the number of copies of things that you need on the system. So if a capability has a requirement for a ROS package, it will first check, is that already installed? And if not, it will install it in an overlay on top of what's already there. This way, we don't have to install ROS in each and every component that we have, which would happen if we were running in Docker containers, right? There would be a lot of duplication, which we can elegantly avoid this way.
That is really cool. So you see if you have it elsewhere, and then if you have it elsewhere, you use it from that location. If not, you install it. That's really cool. So what about handling things? So that handles. I mean, you mentioned a lot of things, and I'm not that familiar with all those technologies. But can you hide things like the environmental variables that one capability can see versus another one, or it just like all of the different things? You give it access to only a small part of the file system. Yeah. Or how does all this work? That's so cool.
Right now, we go with a one-size-fits-all sandbox. You don't actually customize it. We just reduce it down to what we think is all you need. And yeah, you don't see the environmental variables of your user. The home folders are hidden. Certain sensitive folders in the file system, such as var.lib, are hidden from you as much as possible. Like the data, if you're running a database, it would live there, and you wouldn't be able to see that.
Do you explicitly opt into permissions with this, or is it implicit in that, like, oh, this app needs this, and then we'll give it that? I imagine it's explicit, actually.
So right now we think actually we have the permissions down to what most capabilities will need. There could certainly be, some people have asked us about things like user management on the robot, right? This is clearly something that would need administrative rights, and we don't currently support that. We are currently only supporting things. One way to think about this, especially for your audience, is ROS and up. a lot of capabilities run a ROS node. They're able to talk to the other ROS nodes, and that's honestly all they need to do. It's none of their business what I have on my disk, right? That's not what we're here to do. So all of that access is going to be very, very limited.
I see.
Other than say, what you need for ROS operations such as the message definitions, right? But most of the file system will be hidden from you.
Could I? So I'm imagining if I had some node that, so I have a module on my robot, and that's sending up video, and maybe I want to send some sort of thing down from the cloud to say, hey, we're a bit bogged down right now, reduce the video quality you're sending up, or something like this. And maybe it sets that in an environmental variable. Like, could you give it access to that? Or maybe there's a better way to go about doing that kind of thing.
I would have to think about that. If by setting an environmental variable, you mean one that would also be read by all of the other capabilities, like some sort of shared space, that's not currently possible. There is a shared drive space. So another piece of technology that we've taken a good look at is snaps on Ubuntu. And they solve this very elegantly too, where they have of course, containerized or sandbox capabilities, but they also have some shared folders, right, in which you can collaborate if necessary. So that certainly exists.
Gotcha.
In the example of the video streaming, I would argue that that's the capability itself that then reduces that. But
you probably wouldn't need to do it the way I've described. Because the capability would probably just do it, and it'd be setting a variable inside the module, the robot module. That would be probably the best way to do it.
And actually, so we do have that video capability, and we use WebRTC, of course. And one of the beauties of WebRTC is that it will actually do that automatically, right? It will determine, I can't get those frames through, we're going to reduce quality for a little while, and it will adjust to that, which is very nice, and really one of the reasons also to use WebRTC for video streaming.
Do you think that this idea of sandboxing will catch on more generally in robotics? Like, I mean, if I'm using a bunch of software from the internet, you never know if something has been maliciously included. I think
so. I mean, if you've been following what Ubuntu has been doing with their push for snaps, for instance, they had a person there who was also very active in the ROS community, and he was in charge of ROS and snaps on the canonical side, and he was making some very good points as to why snaps are a good solution for that, because they are sandboxed, like you say, right? They are snaps for those of your listeners who don't know. Basically, or you can think of them as Docker containers that run apps on Ubuntu. Now, people will yell at me for describing it like that because, of course, in reality, it's more sophisticated and it actually doesn't use Docker. But for the naive and who knows a little bit of Docker, that's roughly how it works. And so you get all of the beauty of isolation and reliable requirement dependencies and so forth. So I think it's useful. I'm very curious to see how this will evolve and whether the sandboxing will get into the way of development, and whether people will prefer to install their capabilities, quote unquote, privileged. But I think it's a requirement for more broader collaboration, like you said, if we want to enable third parties to run. And it's our fleets of robots, right? I mean, from the perspective of a business owner in robotics, they're very conservative about what gets to run on the robot, because if you screw up, like these
there are implications.
There's a lot of implications on the security side, but also even just on the operational cost. If for some reason your robots one morning don't boot anymore, or they drop from the internet, you can't reach them, somebody is getting on a plane flying somewhere, and that's very expensive.
Yeah, gosh. One thing, a little bit of a tangent, but one thing that I thought was really interesting, and I am hoping more things start to go this way. There's Dino, which is a TypeScript library or a TypeScript runtime environment. And Dino, for using, it's kind of like Node, but better suited for TypeScript, also runs JavaScript. But you explicitly opt into every permission that you want to use. You can say all if you want, but you can say this should only be accessing these folders. This should only have access to this environmental variable, and all of the software that you use can have these permissions set, which is quite cool because, I mean, if you're running software, there's the chance that it's like trying to access something you don't want it to use. And this would be a nice way to vet it. Hey, there was an error. It tried to access some sensitive location. We denied it and the program exited.
That's really cool. I had heard about Deno. I didn't know that they had that feature. I'm actually going to take a look at that. That sounds really useful.
Yeah, I'm sponsoring quite a few Deno projects because I really like the direction that they're going. The whole Node ecosystem is really there's just so much there that it's hard to use Deno for anything that you really want to build. Like I've just been doing it for like command line tools that help make my job at Open Robotics easier. I'll try them in Deno, but lately Node, this kind of thing.
Gotcha. So it's not a replacement for Node.js at this point?
Not yet. There are quite a few packages that are like, I don't know, there's like an Express-like thing for hosting web servers and routing. But if you want to do like really nice date time stuff, or I don't know, there's just a bunch of missing stuff. Or you can go look at the CDN serialization or whatever it is. I don't actually know what that does, but you can go, some packages can be translated over to it, but it has a different import setup. So it doesn't work flawlessly with existing Node things, which is a bit of a bummer. But the ecosystem is growing, and there seem to be a lot of really smart programmers doing stuff on it and building tools.
Yeah, I mean, that's really, I think, key to a framework, platform, whatever, what you name it, a working ecosystem of developers, right? And NPM is my favorite example there. The reason why Node.js is so popular and works so well is because it's so popular and works so well, right? Like people use it for developing more things, and because they develop more things, it's the network effect, right? And then more things exist, and so you can find a library for just about anything, and you don't need to develop it yourself. There's downsides, of course, and we've seen the news about some, either hostile takeovers of packages where people have stopped maintaining it, or sometimes even malicious changes that people made, sometimes out of spite.
To break everything.
And those issues are, of course, serious, and we need to take care of them and be worried about them. But it's a very cool technology to build on.
Definitely. Yeah, I find, so I mean, working at Open Robotics, we use a lot of C++ and Python. And so I have like years and years of using Python, but I really like TypeScript because the defining the interfaces is really nice, and it helps me, I feel like I'm much more productive in it. And so now I'm getting familiar with the Node or NPM packaging and just downloading libraries and software from it. And I'm very impressed, and I feel like it's a lot more capable, in my opinion, than a lot of the Python libraries. And there are obviously exceptions, like Pandas is a really nice Python library that I don't think has a good analog in TypeScript or JavaScript. But just, it's an interesting space.
It absolutely is. And I'd like to point out too that Node.js is actually a bit faster than Python, and that's because JavaScript is compiled just in time. It's not actually interpreted, it's just compiled on the fly, which makes the execution a lot faster. And then I can, say a lot of positive things about NPM as a package manager. It has a lot of features, and it has a lot of capabilities that other package managers I've worked with in the past lack. So, for instance, one big one is having multiple versions of the same package in the repository. You would think that this is a trivial thing, but Debian, for instance, doesn't really support that. In apt, you are not really supposed to have multiple versions of the same package in the repository. But in NPM,
and this is important for your application where you're trying to wean robots off of a version when you're updating them. This is when this would be very useful.
Big time, and also for strict versioning. I think that strict versioning, strict semantic versioning is a real benefit. Where you in NPM there's this concept of a lock file where you will say, I'm going to lock down my versions, and what I commit to Git is exactly this. If you execute this, you will get the exact same result, no matter what any of the dependencies have done in the meantime in terms of updating. You will get the exact same. And this is really helpful when you're dealing with an ecosystem like NPM, where you have hierarchies of dependencies that can be very, very deep, right? You can have
super nested.
2,000 packages being installed as part of your somewhat simple application, and that's a benefit, right? You don't want to reinvent all of those 2,000, but you do want to be certain that if anything happens to either of them, maybe they introduce a bug in the new version, your system doesn't go down. So really locking down the versions and deciding, yes, I want to update or I don't want to update is very powerful. And for that, you need to be able to have multiple versions of the same package in the repository. The other one is, of course, all of the hooks like pre-install, post-install, pre-uninstall, post-uninstall, pre-publish, all of those kind of scripts that you may want to run at different types of the life cycle. They are very powerful in NPM and
really
allow you to do.
I haven't used them
honestly,
at all.
They are very powerful in Debian packages as well, but because NPM has them, you can pretty much install anything through NPM packages that you want, because the payload is just a tarball, and then you run these scripts when it gets installed, and at that point you could install things out of the tarball, let's say even Debian packages or place system files if you have the permissions to do that. So it's a very versatile tool, and I think it's a real good technology to build on and share.
Let's see. So now segueing a little bit, tell me a bit about your open core model at Transitive.
Yeah, this is still in flux, but I am a big believer of open source businesses. I think that there are some very good examples that we've seen in the past, and so we really want to make this open source model work. And from everything that I've learned, there's basically two things that work really well from an open source business model point of view. One is hosting. So in our case, we are offering a hosted solution where the cloud will be taken care of by us. You can still, like I said, have the components and embed them in your own web applications, if even web applications running somewhere completely different. But you don't have to worry about setting up the cloud, dealing with the maintenance and administration of that, storage of data, and whatever your capabilities want to do. That's the one model. Some of our customers have asked about self-hosted solutions, so we are offering that as well, and this is still work in progress, so that has not been released. And the business model in that case is premium applications. So it's really similar, I guess, to Android again, right? Where Android is open source, you can install it on any phone you want. But then the apps in Android can also be free, or they can be premium. And I think this is a good model, right? It allows people to, first of all, get started with it. It provides developers with a marketplace where they can distribute their contributions, their work. They don't have to worry about advertisement and billing and all of that. And on the receiving end, the companies using those capabilities will have an ecosystem with ratings, with commercial support behind it, that they can rely on. So I think that this is a model that can really work.
Gotcha. And so, are you experimenting between those two models, or you'll think that you'll kind of see what capabilities you have and then possibly add? Well, actually, it seems like it makes sense to do the Android model for what you're talking about, where it's and then you're doing both in a sense, because you are providing the hosting, but you're also possibly going to have specific capabilities that people can opt into by purchasing. Kind of
that's exactly right. And both are evolving. We will have to see which one will be more popular and how. For instance, what we are still keen to find out is to what extent will people prefer the hosted solution versus self-hosting. There's definitely pros and cons with both. Some people really don't like the idea of relying on a third party, especially if it's a startup, right? Because it multiplies the risk.
You never know. Yeah.
That's why the ability to self-host is certainly desirable. Others really don't want to take care of the scaling of that infrastructure and would much rather outsource that. So this is like Mongo's Atlas service, which I think is fantastic. If you just want to set up a database, you don't need to set it up yourself and manage it.
Yeah.
But time will tell, really, and we're curious to hear from more people what they think. And also on the premium app side, there's this additional persona of the third-party developer, right? Are people interested in developing for this platform? I think so, and I've spoken with a lot of people who have been working on specific capabilities, a lot of them in the ML or computer vision space, that they want to market to robotics companies, and they like the idea to not having to do all of the legwork in terms of marketing it and figuring out deployment and so forth.
Having more of an app store-centered approach. Yeah, that would be super cool. I would love if we had that kind of thing in the robotics ecosystem. Just like Ross really solves a lot of problems, making it easier for people to build applications, but it's hard to get it outside of your robot, as you're saying, as we've kind of motivated with the whole first part of this conversation. And so if it was like, you just try to you just add different capabilities on through an app store like setting and you can use them elsewhere, that would be super cool.
Yeah, that's the idea.
Gotcha. How have you guys been funded so far? And would you talk a bit more about the team and everything?
The team is very small. You're looking at it.
It's just you.
So I'm the only one fully committed right now in doing technical development. I have I have a small list of advisors. First and foremost, my previous co-founder, Bob Bauer, he was at Willow Garage and he's still advising me. But he's not a developer, so there's not too much for him to do right now. And funding, it's completely bootstrapped right now. We're profitable in the sense that I'm doing consulting work for customers, helping them both doing custom development and then helping them figure out how to use Transitive as well, which is a good model. It's as you can imagine, you don't get rich doing that, but it keeps the lights on. And one thing that I've seen with robotics companies, one way that they have failed was that once they take money, they have to spend it. Because your investors want to use that money to hire a bigger team and scale faster, which means that you are locking in a certain product, a certain business model, and a certain market fit. And if the market fit is not great, then you're trying to scale a business that was not meant to be. Then you're you're digging yourself a hole. And I really want to be certain that we have absolutely nailed market fit, that we have gotten adoption, that we have validated that this is something that people want before we take on money. And so by consulting, that actually solves two problems here. Because number one, yes, there's some money coming into the bank. And number two, we are actually getting validation from our customers. So this really lends itself to an iterative process that will make sure that we will build the right product for the right audience.
Market fit. Yeah.
And I think at that point, we would be able to raise no problem. We've had conversations with investors. They like the idea that we are basically indexing on the robotics market. And what they mean by that is so they have the choice of which companies to invest in. And they know that in robotics, the differences are stark, right? One company may be doing apple picking, the other one may be doing drywall construction, and another one may be layout printing, and another one is doing delivery on sidewalk, another one on the street, and they don't know what to invest in. They all know that robotics is going to go up, and there's plenty of studies by IFR and all of those ABI research that tells us it's going to go through the roof. It's a phenomenal technology, and we're sort of at the starting point. They all want to invest, and they don't know where to invest. So what they like about platforms like this is that they know that if robotics will succeed, this company will succeed as well.
Gotcha. That's really cool. I really like bootstrapping too as a model in general. Like Because one of the other things with if you take investment is you kind of commit yourself to a timeline that you will have some sort of liquidation event within some period of years, like typically less than 10, maybe closer to 5 years, that the investor would like to see a return on their investment. And that's tough because, as you said, you have to like really commit to the current fit, and it lends itself to a certain type of product. That being said, like Cobalt Robotics, they're doing the investment route, and they're doing a phenomenal job as far as I can tell, which is really interesting if you position everything well. And it'll be cool to see kind of if you start accepting investment and how that helps you scale. But once you've found that really good market fit, that seems like a very good approach to me.
Yeah, I'm keen to getting to that point, and I do have a concrete plan on how to use that money, namely to foster third-party development. I think there's some really interesting models that you can follow. I think that there are a lot of capable developers out there, and I love this idea of a marketplace because it has inherent network effect. The more capabilities that we have of high quality, the more people would want to use it. The more people who come to our app store to look for capabilities, the more people want to develop for it. And so that's the classical network effect that can actually justify exponential growth. And investors always want to see exponential growth, and I always ask them, well, based on what? Right? It doesn't just happen, right? There needs to be some sort of mechanism behind it, and it's not bouncing a QR code on the Super Bowl in Super Bowl ads, right? That costs a lot of money. No, you have to have something where the classical N+1, right? If the N+1 user has a better experience than all of the N before and makes the experience for all of the N users before that better, that's network effect. That's why you have these convergence effects where everybody will use, for instance, the same social network, right? If you're the only, if you and I go onto a social, create a new social network, and we're the only users, well, you and I can have great conversations, but it's not as useful as if there are more friends of ours on that same thing, right? And so for everyone that we add, it gets better. And I think, marketplaces have that dynamic inherently built in. They're also hard to pull off, and that's where money can be really helpful. But I think first and foremost, you have to make sure that it goes about it the right way, and openness, and I think is really the key to all of that.
Huh. Tell me a bit more about that. That seems very interesting.
Well, I just think that if you want to establish yourself as the framework that everybody develops on, and then contributes to your store, and I'll use the Android example, right? Then being open is really is really the best thing that you can do, because you're going to benefit in the long term from people being on your platform, and you will find ways to pay your bills, right? I like this quote from Eric Schmidt when he was still the CEO of Google. They asked him back in the day, so Eric, how are you ever going to make money from Android? And he said, in 5 years, there's going to be 1.8 billion users using Android. We'll figure it out. and I think it was brilliant. And of course, he wasn't the first. Microsoft obviously famously gave away MS-DOS for free at a time when others were charging for their operating systems. And we all know what that did, right? People started installing MS-DOS on their phones, just like Android was free, right? And they installed Android. And now there's a big market for Android applications. And so that can be monetized. And I don't say monetize in the sense of, really making as much money as possible. It's more about making enough money to do a good service and to keep it running and to make sure that it is serving everybody involved in the best way.
Yeah, you can invest it back into it, and it's basically more ability to make larger impact in the future. And then you just, that seems excellent. That is a good model. It's interesting to consider the network effect. I had been previously thinking of kind of like a zero replication cost as the way to get towards exponential growth, which is like, coding is a good example. You code it once and then you can use it anywhere. But network effect seems like a very good thing to think about, especially when thinking about like a marketplace. and this kind of thing, because as you get more products on there, it becomes more valuable. So the N+1, as you're saying, more valuable than all the previous people.
Venture capitalists, especially in the SaaS world, look at one ratio more than anyone, more than anything else.
And that's software as a service, right?
That's software as a service, yes. They look at one ratio more than anything else, and that is the lifetime value of the customer over the customer acquisition cost.
Oh.
And they mostly they know that the customer acquisition cost at first is tremendously high. They are totally fine, or they almost expect you to spend 3/4 of all of the money that they will invest in you on customer acquisition, which sounds mind-boggling at first, right? Why would you spend so much money just to get users? Why don't they just
to get that network?
That's right. Yeah, but and that's why these network effects are so valuable from a growth perspective, because it becomes cheaper and cheaper to acquire new users. Facebook, when you think back, until not too long ago, they never advertised anything. It was all word of mouth. And of course it was, because if I'm on Facebook, I will actively recruit my friends to come to Facebook because, hey, I don't want to share my photos both in email to you separately and then also on Facebook. And also I want to know what's going on in your life, right? I would love to see that. And so my friends, are intrinsically motivated to recruit friends, or it doesn't have to be friends, it can be developers and colleagues and whatnot, then there's a real good chance that things will grow. And so I think for that, this concept of giving back in some sense is important, right? If I'm a developer on Transitive, I will be recruiting people to use it, right? I will advertise the fact that I published something on Transitive, and sure, the focus will be on what I have published, but in the process, I will still be advertising the platform as well, and then people may go, oh, yeah, I've been consuming capabilities through Transitive, and we have developed this cool new, whatever as it is, map display, map editing tool for robotics. We could publish that back as well.
What do you think will be, so kind of going from where you are to starting a marketplace of different capabilities, what do you imagine, like how will you get from here to marketplace?
Yeah.
How are you thinking to proceed?
So marketplace is, of course, the longer term vision and aspiration, and you can't even build a platform from day one. You have to go vertical to horizontal. You have to have something where your early users will get some real value out right away before they even recognize that there's a platform and that they can do more things. So that's why we will develop certain capabilities ourselves, and on our website we already have 3 that people can use right away. And ease of getting started, I think, is really important there. So if people within 30 seconds can have a remote video streaming capability, which they previously thought would take them months to build, that's a great experience. And I think that's something that we can market and start growing on. This is actually, again, going back to Facebook, not very different from the way that they got started. If you may remember, they were first just an application for students at Harvard, right? And then for a while, they were just for college students. And then they broadened out like that. And it's a nice model, because when you think about it, first you basically conquer a small pond. But you try to get to something like 90% users, like 90% of the people in that pond use it. And of course, at that point, okay, you've convinced yourself that first of all, people want that. Second of all, the network effect works. And these people have friends outside of Harvard, right? So they will talk to them, and they will talk about Facebook, and people go like, well, I can't use it yet. But so that creates some sense of desire. And I think that's really my model of vertical to horizontal. You want to start with something that is very small, where you get a lot of value for potentially a very small market at first, but leave absolutely no doubt about the fact that there's
how
value.
Great it is. Yeah. How do you think you'll get your first Harvard or whatever in the robotics community? Is it the video streaming app or that people will be using, or or is it some set of the ROS community, or what do you think?
So we definitely target the ROS community right now. And specifically, we're actually targeting the ROS 1 community, which may surprise some of your listeners.
I was going to ask if it was ROS 1 or ROS 2.
Yeah, so right now we're focusing on ROS 1, and that's for a very simple reason. from my experience, everybody who has an actual fleet of robots out there that grows
Uses
is still
ROS1.
using ROS1. And I wish it was different because I think ROS2 has some really nice features, but until not too long ago, it wasn't necessarily perceived as really ready for prime time. And we've seen all of those discussions on Rust Discourse and elsewhere. So the vast majority of robots out there are still using ROS1. And so breaking into that would be sort of the first step. The platform that we build is not specific to ROS2 or ROS1, but the capabilities that you will build are. And then in terms of which capabilities to focus on, yeah, I think low latency video streaming and remote teleop are some very good ones to get started with. We know from some of the existing offerings that those are some of the most popular features. In fact, there are now companies like DriveU and Phantom Auto that offer specific remote control capabilities for originally self-driving cars, but now they are doing a lot of business with auto delivery robots. So there's an absolute need there, and so I think that's a good way to get started.
Let's see. Is there? Well, I guess. Do you? How do you imagine your team will grow over time?
I mean, this is, of course, a little bit of a chicken and egg question, but we have to first get some traction so we can hire and then we can get a team. But of course, in order to hire, people may also want to know about that strategy. At Savioke, my entire team was remote, which at first I thought is not possible for a robotics company because we're dealing with hardware, right? How can you do that remotely? But I learned there that it is absolutely possible, and it has some real big benefits, like on so many levels. Like for one, you can tap into a much broader pool of talent, right? There are great developers all around the world, not just in Silicon Valley. It also solves another problem that we have here in Silicon Valley. There's housing is insanely expensive because everybody wants to live in Silicon Valley. And why? Sure. If we can work remotely, we don't need to make this housing market here any worse.
I know.
and yeah, so I'm a big believer in hiring remotely. We have worked in the past with people. I had people on my team from Germany, France, Spain, Argentina, several places in the US. One of my employees actually was driving his RV through the country, and almost every meeting started by asking, "Where are you today?" And sometimes he had to apologize because there was not enough sun to use his solar panels to charge his batteries, but that happened very rarely. But it worked, and I thought it really added to the diversity and the kind of perspective of the team. So I want to follow that same model and focus on, like, build a remote first kind of company.
Yeah, that seems super cool. What are some of the, because you seem to, like, you've been implementing everything. So I imagine, like, I'm wondering what will the first people, what will their roles be, do you think, as you start to grow, or as you start to have more interest and investment and then have the ability to hire some people? Where do you think you'll start?
I think we will be hiring mostly on the engineering side, and I will be handing off more and more to my team and focus more on the leadership and sort of external facing requirements. I also before long will hire a product manager because I think it is actually really important to really feel customers out and understand what pain points they have and how we are addressing them. And I'm also just going by things that I know myself I'm not very good at. That's perhaps the best advice that I ever got for hiring. The time to hire somebody is when you can find somebody who can do that role better than you. Not before that and not after. And it's not, sometimes people think of, oh, I'm too overburdened. I should hire somebody to do these things. But if you then don't find somebody who you really trust to do it better than you, it's too early to hire because you will be questioning them and perhaps micromanaging. That will not make anybody happy. So a lot of it will have to do also with finding the right people at the right time and filling in until then yourself, which again is fine while you're bootstrapping. And then once we've raised money, there will be a slightly different question, but that will still, to the extent possible, be my model.
Gotcha. I really like that model. It's interesting because I mean, you think if you hire someone and like it is to take weight off your shoulders if you're trying to do everything, but then if you don't trust them to do the work well, then it's like, well, now you're micromanaging, and now you have that job still through micromanaging in a sense.
I think it goes back to the question of accountability versus being responsible. I think at the end, what you need is people who distribute onto whom you can distribute the accountability, people who you can rely on being accountable for something happening, and having that attitude to say like, well, maybe I wasn't supposed to be working on this. Maybe it was somebody on my team, but it's not there. I'm going to fix it. Right? That's kind of the attitude that you need. I've seen this in engineering teams a lot. Like sometimes the amount of features that you need to implement, you just have too many features or too much code for the size of your team. There needs to be. I always think of a tent with tent poles. A tent where if you have 2 or 3 tent poles, you can cover a lot of ground just by spanning something over it. But at certain points, you have to hold up the tent. You cannot with one tent pole cover a lot of area, because the analog there, or the explanation there is what the amount of code that you are responsible for as a developer. It cannot be infinite. One developer can be responsible for 100,000 lines of code. A good rule of thumb that I have is between 10,000 and 20,000 lines of code per developer is a good number. Beyond that, you will just not be very effective, because if every time you switch tasks, you have to refamiliarize yourself with the code that you're dabbling in, then you are in trouble, right? And so getting that ratio down is quite important, I think.
Gotcha. Do you think that's kind of the way to proceed, where you have people, in a sense, specialize on specific spots of the code? So 10 to 20,000 lines per person, where they kind of like divvy it up. Yeah. And each person has like a little silo, in a sense?
Yeah, I think so. And I think with our architecture in particular, it lends itself to that, because we have the framework itself, which breaks down into the components for Robot Cloud and front end. But then we also have the capabilities, which are super important, right? I mean, they are by design standalone. So you don't, in fact, it is a good thing if you are not too familiar with what's going on in the platform, because you're supposed to treat it like a user, right? The documentation says I should be doing this, and that's what I've done, and it doesn't work. Okay, thanks, file a ticket, but you don't have to fix it. I will fix it, right? And I think that's how we can divide it up, and also find interesting ways of working together, right? So, when you're working with a remote team, sometimes it's preferable to have contractors rather than employees. People may not want to commit their time completely, but only into part of their time. And so having this actually a product which is componentized like that lends itself to offering all sorts of ways to work together, right? If somebody wants to work half-time on this and really just wants to develop a specific capability, but wants to get paid for it rather than selling it on the marketplace afterwards, that's great. We'd be open to that.
That's super cool. It's very flexible. I hadn't thought of that kind of model, where someone can be hired as a contractor just for a specific thing that they want to add, but it's maybe too large to take on as like a free project or this kind of thing. Very cool.
Yeah, I think since the pandemic, we have seen more and more models for how to work remotely. And of course, there have been, even before the pandemic, there have been things like, I think, Upwork and Fiverr and these kinds of tools or platforms that allow you to outsource some work. But I think there's a spectrum of, from being a full-time employee to being an hourly contractor for a short time. There's a lot to be explored in between. And only because you're a contractor, for instance, doesn't mean that you can't be treated like an employee. I mean, it's just, to me, that's just the bureaucratic aspect of what are you called on paper. But the relationship can still be that of an employee, and location shouldn't matter for that at all.
Yeah, for sure. Especially, I feel like with programming tasks. I mean, we work on GitHub, you do reviews and things like this. It works really well asynchronously, is what I'm struck by so far, being at Open Robotics.
It does when you're set up for that. One thing that I've seen, and I'm, of course, comparing notes with a lot of my friends at other companies, one thing that I've seen especially with some larger companies in the Bay Area that frown upon remote work, and I'm not going to mention their name. They have this problem that like 90% of the people until the pandemic were in the office, and so anybody who was remote felt left out. Right? There were a lot of decisions that were being made in in-person meetings that were not documented and so forth, and that was really hard for the remote team. But if you set up like a remote-first company and some people just happen to meet in the office, it's a completely different ballgame. Every decision will be made in a ticket, and everybody can chime in. Everybody can see what the record was, what led to it. And that has so many benefits, not just for inclusion of the remote team, also just for refreshing your memory 2 years later.
Yeah, I was going to say future you.
Future you,
like,
exactly.
It's well documented.
I always think of it like that. Every time I write documentation, I'm telling myself, I'm doing my future self a favor here.
Yes, for sure. Awesome. Now, I would love to get your thoughts more on web and robotics, kind of how you see. And actually, starting it super broad, how do you think web and robotics kind of, I don't know, like what do you see as the relationship between the two, like web tools and robotics?
Yeah, I mean, obviously, I'm a big believer in web tools. I actually have another bootstrap company that is based on web technology. It's for scientists. I've been running it since 2006. So I've gone through this whole process of web development and really learned to love it. What I'm struck with in the robotics community is that there's still a little bit of a divide. There's sort of a I sometimes call it the group of believers and those who don't yet believe in web technology. The tools, I love ROS, but some of the UIs like Qt, it's not up to snuff these days anymore. It's not developing as fast as web technology is. It's not as accessible. The benefits of web technology, perhaps the biggest benefit of web technology is that everybody immediately has access because they have a web browser on any device that they have, right? The desktop,
super portable.
Linux, Windows, Mac OS, some people, I think, still run OS 2, whatever you want, right? And you can have it on your phone. You will have access. You don't need to run Linux to visualize something, for instance. So I think that by itself is perhaps one of the biggest benefits. And it kind of enables a broader group of users too, right? So at Savioke, we had a very important part of the company was field ops. Because, of course, at Savioke, we were running robotics as a service, so we were on the hook for making sure that our robots work in the field. And if there was a problem, we wouldn't just, it wasn't our customer's problem, it was our problem. We would fix it. And so monitoring the robots, triaging, and so forth, that was a big part of what we did. But we didn't want to have engineers do all of that because engineers were busy writing, improving the software. So we had this role of field ops engineers. And they may not know much about ROS, nor do you want to train them in ROS. That would be a real big limiting factor for hiring. So being able to give them tools that they know how to use really enables them, lowers your cost, makes everything easier. And so there's a lot of good reasons, I think, like that for web technologies. And now I think what we need to do is collectively build the tools to make exactly that development easier. You and I meet on the ROS Web Tools working group every 2 weeks, and there's a group of others, especially the folks from Foxglove, who are very active on that. And I think it's great that there's all of these contributions being made. And I think that's how we fit in with Transitive as well, like being able to offer a piece of the puzzle that helps with data synchronization across devices and remote robots. Hopefully, will contribute to this open source web technology ecosystem that we can all kind of build the future on.
Do you? This might be a crazy question, but do you ever see web technologies on the back end for robotics applications? So like, maybe like a ROS client library in TypeScript or something like this. Do you think there's a place for this?
Oh, absolutely. I guess I should mention that I'm one of the contributors of ROS Node.js, which is just like ROS CPP or ROS Pi is a native binding for ROS. So it speaks ROS. It just makes TCP connections to all of the other ROS nodes, but it's written in Node.js. It's a native implementation. Yeah, I mean, I personally use it a lot, right? It's certainly not as fast as C++ if you have something that really requires high performance. I wouldn't necessarily use it for point cloud transformations, but if you want to put something together quickly, similar, it really, I think, scratches a similar itch as where you would use Python. Because you can write it very quickly, you can test it very easily because it has an interpreter. And yeah, so for sure. I mean, there are others, right? There's Rust Node.js, which was originally started by Brendan Alexander at Willow Garage. He later became the CEO of Iron Ox, and he was too busy to maintain it. I took it over at one point, and around the same time, the folks at Rethink Robotics started a rewrite. And so the current version of Rust Node.js is based on what Chris Smith at Rethink developed. And there's there's similar libraries for Rust 2 as well. No, I don't think it's crazy at all. I think it's a fine language to develop in. It's very quick to develop in that, and it has this very nice ecosystem that allows you to share very quickly.
Let's see. So where do you think robotics will be, more generally, where do you see us going as a robotics community in the next, say, 2 to 5 years?
Oh, that's an interesting question. I don't spend too much time thinking about that, but I guess I can extrapolate a little bit from my view of the robotics, the startups in the space right now, which I looked at very carefully after leaving Savioke and when pondering what to do next. And one thing that struck me, of course, was and this shouldn't be too surprising, but I still think it's worth mentioning. The successful robotic startups are the ones that find a problem worth solving first, and then convince themselves that robotics is the best way to solve it, and then solve it. Which is honestly that's not always been the case, right? In the past, there were a lot of robotics companies that were trying to solve that hammer nail problem of we have a robot, what can we what to do with it? And so I'm very excited about this new model, and I think that's actually what's behind it. Again, not too surprisingly, behind the success of so many new robotics companies in so many different spaces. I mean, even just what is it, like 8 years ago, there weren't all that many applications of robotics outside of car manufacturing. And then at the time, that was roughly the time when the Kiva acquisition happened. So we were aware of the warehouse robots, which still was sort of a novelty. Apart from the AGVs that were just following simple tracks. And now you look around and you find so many startups in so many different spaces. AgTech is a particularly interesting space, if you ask me. There are so many problems there that that's where I like the title of your podcast, Sense Plan Act or Sense Think Act works better than the blanket approach, because that's really what a robot does, right? It senses, it decides what to do, and then it acts. And when you look at, for instance, what Blue River does in AgTech, right? They will go over a field, and rather than applying pesticides everywhere, they will actually take a good look at the crop that is growing, and they will decide how to act, like where to apply pesticides. And the amount of pesticides that you use as a result is, of course, much lower, which is fantastic from an ecological point of view, but also is a very good business proposition. You're growing better crops, and then that's I really congratulate you on the choice of that name for the podcast, because it is core for what a robot does, and it also describes the value very much, right? There's so many areas that we could explore with this mentality of where are we currently doing a blanket approach where it would be smarter to take a good look, then decide, and then act. And of course, this is now being made possible by better software, better compute that allows us to implement algorithms that do sense and that do think, right? That wasn't necessarily possible before. And I think it's super exciting. There's one particular area that I'm very curious of, and that is this whole idea of a mixed initiative operation.
I don't know what it means.
So any sort of teleoperation where you are not controlling the robot entirely, but only perhaps giving certain signals and then having the robot do other things, kind of falls into that category. And I think it's a very interesting space to look at, because another thing that robotics companies in my mind have done wrong, and I'm saying that now, I would have made the same mistake until a few years ago, but they made the mistake of trying to automate everything from the get-go. Whereas nowadays, you see a lot of very successful robotics companies start with fully manual approach, remote controlled, and basically say, let's own the problem first. Let's own the business problem first. Let's build the customer base and then automate it more and more and more to reduce our cost. And I think that's a fantastic model, because you will be learning and you will know what to automate in the process. And the most of the value may actually come from something that is relatively easy, right? So I'll give the example of sidewalk delivery robots. I personally have to admit that I was laughing at Starship when I first saw their robot, because I looked at it and go like, you will never be autonomous. And they laughed back and said, we don't try to be fully autonomous, because they basically recognized, and they have evolved a lot since then, but in the early days, they've recognized that if they have a robot that can reliably drive forward without bumping into anything and noticing when there's an obstacle and just stop, as opposed to doing all of the great, path planning, like the stuff that you've discussed with Steve last time about, going around obstacles, dilating the obstacles, and dealing with all sorts of situations. If you just focus on this one thing, then all of a sudden you can have one pilot control whatever it is, 10 different robots at the same time, because most of the time they are actually driving by themselves. And then when they get in trouble, they will ask you a question, but you just, we're pretty quick with our wit, we humans, right? We see the situation, we decide what to do, we tell the robot what to do. And so that way you can really kind of make a step function a gradient, right? And of course, anybody in machine learning will tell you that that's the secret behind all of machine learning and neural networks as well, that if you have, yes, in the end, you may need a step function, but to learn it, you need to smooth it out. And by smoothing it out, by giving a way to move along that spectrum between full automation and fully remote controlled, really enables a lot of innovation. So I'm really curious to see what will come from that. From a kind of vision point of view, I like to, I sometimes ask myself whether it will be possible to make everybody in the world able to work remotely. And what I mean by that is we've seen it during the pandemic, right? There were I would call us the fortunate ones who were able to just work remotely, and those whose job required them to go in, and they had a big problem. Either they couldn't go in because it was shut down because we had lockdowns and they suffered economically, and that caused a lot of hardship on a lot of people, or they were able to go in, but they sometimes suffered and had to take the risk of getting infected more easily with COVID, and that's exactly what happened. So almost from a fairness perspective, I asked myself, well, what would it take to automate all of not automate, but make it possible for everybody to work remotely? And we've seen some very perhaps eyebrow-raising examples of that, of humanoid robots being remote controlled to stock shelves in 7-Elevens in Japan, where somebody was remote controlling the arms to take cans out of a tray and opening the fridge and putting them in there. And people laughed at that, but I actually think it's tremendous. It's exactly how we should be thinking about it. And if you start by remote controlling that and then ask yourself, well, which of these things can we actually automate and which ones are the really hard ones, and just identifying the problem and phrasing it well, there will be actually no shortage of people who will be interested in solving that. I mean, both of us have been in academia for long enough to know that in academia, often the problem is finding the problem, like finding a real problem that fits my solution, right? And so there's almost a thirst for problems. So if we as sort of the ecosystem of companies in robotics can identify problems worth solving and frame them really well, so that we can sort of hand them over to academia. Academia would love us, and we would love them back for the solutions that they give us. And I think that's like building bridges like that between academia and applied research and robotics in particular is something really worth working towards. And I think it's really exciting.
Mm-hmm. Awesome. Well, I think we'll end it there. Thank you very much.
Thank you, Audrow.
Bye, everyone.
Thanks for listening to this conversation with Christian Fritz. Thank you again to our founding sponsor, Open Robotics. See you next time.